Hi everybody, and thank you again for watching another episode of Gaffer and Gear. Finally, I'm having a look at the Aperture Infinibars. So this is their 8-piece, 2-foot kit. All right, so let's start off the review by explaining why this review is so late. I mean, everybody else reviewed these 4 months ago. How come I'm only just getting around to the review now? All right, so we had a bit of a mess up. Okay, so there's nothing wrong with the lights. They work fantastic. There's nothing wrong with the firmware. The problem we had was an administration error. So when it came to the customs declaration form, somebody ticked the wrong box or something like that. And the entire Aperture shipment that was coming to me, every product I meant to review this year, got seized by Australian Customs. So if you've ever dealt with an Australian government-run department, you know nothing gets sorted out quickly. So it took about 3 to 4 months to get the all the paperwork and everything sorted out, and to get the shipment released and then over to me. So that's the main reason I'm behind. This episode was meant to be out probably about 5 or 6 days ago, but then I got a panicked message from Aperture saying, hold the episode, there's been a new firmware update. So these have got a brand new, couple of days old firmware in them. And that's also affected the episode. So I've had to pretty much reshoot quite a bit of the episode. Here are the main things that have been fixed in the last firmware. Firmware updating. You can now update the firmware on these via the USB port, so you don't have to do it over the Sidus Link app. So the last firmware update I put into these over the Sidus Link app to do the 8 kit of these took 58 minutes. So that's a killer if you're a rental company. You can't spend that sort of time, 58 minutes per 8 kit, updating your firmware. It's not a possibility, but now you can update over USB. And the other thing that's changed too is there's now some DMX smoothing options in there as well. All right, let's go over the key points of difference between these and other lights. So the first key point of difference is pixel density. All right, so these are available in 3 sizes. The smallest is 1 foot, and the 1 foot has 24 RGB WW pixel zones. The next size up is the 2-foot versions here. These have 48 pixel zones, and the largest version currently available is the PB12, which is 4 foot long and has 96 RGB WW pixel zones. The next obvious point of difference is the shape. These are not a tube, they're a square or a bar. All right, so why have they done that? Well, that's intentional. So let's have a look at a Titan tube. So on the end of the Titan tube here, you've got this section that doesn't illuminate. If you were butting tubes up together, you'd have double that width of non-illuminated area. Whereas with the Infinibars, they have an illuminated area that goes from edge to edge. So the idea is you can link these together, and as the name suggests, Infini, you can have an infinite length of illuminated area. Now these are sold with joiners. Now you get these flat joiners that come with them, but you can also buy a joiner kit to make different shapes. So let's join the 2 of these together and see how it looks. All right, now you're probably looking at that thinking, well, that's not that infinite. I can see that there. Now, you probably wouldn't be using something like this in your face. It would probably be a little bit further back and maybe running a full saturated color and brighter than this. So let's have a look in that scenario. Okay, so it's very hard to see that join now. You've got an infinite line. Okay, now with the Infinibars, it's not just an infinite possibility lengthwise, but also widthwise, because it's edge to edge, top to bottom. Have a look at that. Okay, now again, so in your face like this, you can see that there's separate segments, but a little bit further back, a bit more light on the product, or a bit more light coming out of the product, and that's very hard to spot. That looks like an infinite light source to me. All right, let's continue on through the pros. So one of the pros of this shape is it has a rail built into the back here. So each InfiniBar is supplied with this clamp, which easily mounts onto the rail and gives you a very secure connection. Now, the advantage you've got here is you can reposition this along the entire width of the rail. So the one advantage this has that I've found is if you're trying to create shapes in the background and you've got tube lights on clamps, inevitably at some point you end up with your spigot on the tube light and the weight on the left side of the thread. And in that situation, they just unthread and end up tilting. But that doesn't happen with these because that's a secure connection point. And also, if you do need to, say, mount this to a articulated arm or something like that, it does have a thread in the end of the spigot there, so you can mount to it. Now, in terms of other mounting points, you've got mounting points at either end of the tube. You've got a thread. And at either end of the light, on the back, you've also got 4 mounting points, which can also take a standard industry spigot. Now, those mounting points are for the joiner kits. Now, they come with these flat joiners, but you can also get a joiner kit to make different shapes. Now, in the center here, there is a DC power outlet, so you can feed power through the joiners from one light across to the other. Okay, so that's called power sharing. Now, just a couple of things with that power sharing. You are limited in how many you can link together and run power through by the transformers that you have. The transformers that come with the lights have a picture, and that picture shows how many lights you can run. So on a standard transformer, you can run up to 4 foot of InfiniBars. Now, at the end of that 4-foot run, you'd need to put another transformer in, okay? So if you don't do that, you're just stressing the transformer, you're not getting enough power going through, and you could also be increasing the amperage on the pins here. So, just make sure you're running the correct amount of power distribution over your set of InfiniBars. Now, Aputure also have now an additional optional extra power supply that can run up to 16 foot of InfiniBars. Now, just a note with the power sharing through the mounts, it only shares the power coming in off the power supplies. It doesn't share the power from the internal batteries. Now, on the back of the lights, there are integrated magnets. Now, on the 2-foot and 4-foot, you've got magnets that can slide around on the bar here. So a lot of people are saying, hey, this is really, really handy for mounting. When I first came across this back in beta testing, I was really confused because I thought, well, that's going to help me mount it if it's horizontal, but if it's vertical, well, it's not going to securely fit. So I was a bit confused by this. So I asked Aputure what they were thinking, and they're actually not designed for that sort of purpose in mind of being able to reposition where the magnets are for mounting. They're actually to make these compatible with the 1-foot units. So with the 1-foot units, to fit all of the electronics inside these, the unit actually had to be physically fatter. Now, with these slidable magnets, have a look at the height that that's sitting at. You can see that matches the height to the 1-foot unit. So if you're mounting them to a wall and you've got 1-foot units in the mix, everything can be the same height. Now, I would recommend, if you don't need these magnets on the back of the 2-footers and the 4-footers, I would recommend taking them off, particularly if you're using the joiners, because what I found with the joiners, if you go to Allen key anything and you've got the magnet on there, the Allen key will get pulled straight to the magnet every time. Now, something I forgot to explain is underneath the movable magnet is another magnet that's permanently mounted to the light. Other pros include very solid build quality, an easy to use user interface. You can select the battery runtime for the duration of your shoot. With full saturated colors, they are brighter than anything else with a similar form factor. And my personal favorite, built-in CRMX radio control. Now, a lot of RGB lights can't generate a decent yellow, but these lights can. But just a note, you've got to dial in 49 degrees on the color vector. All right, so let's start going through my list of negatives, and the big overwhelming negative for me is these don't have a rain protection rating, so you can't use them outside in the rain. That is a real shame, a really big negative, I think, for a lot of staging people. Okay, now let's get into my next negative, and this might sound a bit fussy, the joiners. So the threads on the joiners use a 5mm Allen key. So what's my problem with that? Well, I don't know if there's an industry standard, but everything else I've got that uses an Allen key uses whatever size bit this is. I've got no idea what bit that is. Now, this literally is used with everything else to the point where I have super glued this into my ratchet so that I don't lose it. I mean, I never ever use any other bit. So my concern is I think a lot of people, they're going to have that size ratchet, Allen key connection in their toolkit on them. They're not going to be carrying something like this around. And I think they're just going to go, you know, oh, well, close enough, and it's eventually going to rip these. Okay, let's get to my next negative, the side of the units. Okay, so if you're using a tube light, for example, and the camera is sideways to it and you can see the side of the light, you can just rotate the tube around in the clamp and have the illuminating surface facing the camera. But with the InfiniBars, you can't do that if they're mounted to a wall because they're not a cylinder. There are some limitations in the app. We'll talk about that in a sec. And these lights are definitely not high-speed flicker-free. And this is my last possible negative. If you're looking to buy an 8 kit of the 2-foot InfiniBars, it is sold in the same road case as the 4-foot kit. So I think when it comes to this, you're either going to love this idea or you're going to think it's absolutely stupid. I don't think there's going to be any middle ground on this. So if you're a big light staging company or something like that, you probably love this because it's a modular case. So you can reposition the dividers, and in each of these rows, you could fit a 4-foot InfiniBar, 2 2-foot InfiniBars. You could even fit 4 1-foot InfiniBars and be able to charge them in the case. So in terms of modularity, that is a sensational idea. That works really, really well. But if you're buying a 2-foot kit because you can't fit a 4-foot kit in your car, or if you're an owner-operator like me who works by yourself, this thing is incredibly heavy and ridiculous. This is a 2-foot kit. Look at how much space it could take up in a small location. All right, so let's go through what's in the kit. I'm not going to go over pricing today because there are so many variables. You've got 1-foot units, 2-foot units, and 4-foot units, different size kits. You can figure all that stuff out for yourself without me making a mess of it. Okay, let's start going through. So in the case here, you've got a charging station, and that charging station has 8 outputs. So you can charge all 8 rows. Now, if you want to charge more than 8 at a time, you can remove the dividers and use the joiners to charge additional InfiniBars. Now, the top section where the InfiniBars are stored lifts out to reveal all of the accessories below. But before you do that, make sure you've got it balanced. So if you've got an 8 kit of 2-footers, make sure you've got 4 on one side and 4 on the other side. Otherwise, you can make a bit of a mess. Now, as you can see, there's a fair bit included in the kit. So you get 8 individual power supplies, so you can run each of the InfiniBars separately. And you get 8 of your regional power cables, which are IEC connectors. There's enough space in here to fit 8 of your optional DMX cable adapters. Over here we get 8 of the joiner plates, and there's room in the kit for 16 joiners. Over here we have 8 of our mounts, and we've got space in the kit for 16 of the mounts. And over here we've got 8 of our grids. Now the InfiniBar grids just mount using elastic and Velcro. They have solid cell walls and they work pretty good. Okay, so let's have a look at what control we've got over these in the Sidus Link app. All right, so we're going to look at what I call flow effects, where a pattern flows from one light onto the other and onto the next. Okay, so once you've got your scene selected, click on that. Now down the bottom you'll see a pattern symbol. So click on that. And this is your Magic Affinity FX program. All right, so it's the easiest effects program I've come across in terms of having a pixel flow effect like this running. Incredibly simple to set up, but it does have some limitations. All right, so the first thing you do is select your shape. So you do that by clicking up in the corner. There are various shapes that you can select from, and you can buy a kit of joiners that will enable you to make all of the shapes that are here. I don't have that kit. All right, so just to give you some idea, you can do quite a few different shapes. So this shape here, it starts off, you can select the size of it. So we've got 1 foot edges, and we can go all the way up to 20 foot edges. So it gives you some idea of the scope of the program. Now, in total, the program can run 1024 pixels. All right, so let's start off with a nice easy shape that I've already got set up. Let's go a square. So I click on the square. Now I select the size of my square. So I want to go a 2 foot radius by a 2 foot radius and hit confirm. Now I've got to select my bars, my infinity bars, and place them. So down below is a list of my infinity bars. So let's click on the first infinity bar and figure out which one it is. So if I click on the circle, that's my identifier. So, okay, that's a bar that I want. So I click on that bar, and then I click on the picture where it is. Okay, so there we go. So I've got that bar assigned. Let's have a look where the next bar is, next one down. So I click on the circle. I don't want that one. Okay, let's try the next bar. All right, so I want that one. Okay, so now I click on the name, so I select it, and then I click on the picture where the bar is, and it's in the top. Okay, and we continue through doing this process. Let's see if we can find the next one. I don't want that one. Let's try the next one. Okay, select that tube, click on where it is on the diagram. Let's see if we can find the next one. There it is. Click on that and click on it on the picture, and then I click my tick button, and we're done. Now it asks me if all of the lines, the test pattern, is moving in the same direction. Now, if I've got a tube set up the wrong way around, I don't have to physically remove the tube. So let's go adjust. I'm going to deliberately change the top one so that it's wrong. See, it's going the wrong way. So if that's the only one that's doing the wrong thing, I just literally click on it on the picture and it'll reassign it. Now, once they're all going the same direction, I click perfect. And now it syncs everything up. Okay, so that takes a little bit of time. Okay. All right, let's run a rainbow effect now. So the thing that impresses me with this is, number one, how simple it is to set up. That is super easy to set up. The next thing that impresses me is the sync. I've set up a pattern with 8 of the bars, and I couldn't get it to go out of sync. Even at full speed, I couldn't get anything to change. It just stayed perfectly in time. Now, let's have a look at some presets I've saved earlier. So let's load up this one. So I've got a basic chase there going. So let's get the speed up on it. You can see it stays in sync. I mean, I've only got 4 tubes here, but I tried this with 8 tubes and it stayed perfectly in time. Okay, so I can do things like adjust the length. Okay, let's go to another program another save I had earlier as well. So there you go. You can see it stays beautifully in time. All right, so let's go over the negatives now. There's not a huge amount of pre-programmed effects in here blowing my hair back. Pretty much you've got a rainbow. You've got pretty much solid color. Okay, so in this integral mode, you can do things like a gradient, which I've got here. I've got a CCT gradient. And then you've got your sort of pixel mode. So in your pixel mode, you can change the background color. You can change the width of the flow that's going. You can change the color of the flow that's moving around, and you can add a gradient to that color. So I think I've got a gradient programmed in here. Let's take a look. Okay, so see, I've got a gradient of color moving around. So there isn't a huge amount of effects like you'd have, say, in the Astera app. All right, now let's get into what I think is the biggest negative with this app. And I was really surprised at this when I came across it. And I'm really surprised that nobody's really mentioning this. Okay, so I've got 4 infinity bars running here, and I've got a kit of 8. So I've got another 4 over here as well. All right, so let's try and set up a second square doing the same thing, okay? So I click on the top corner, select my square, and here's the problem. This app can only run one single shape at a time, okay? So if I confirm and I want to program this shape here, then this one turns off. So you can only run over the app one single shape at a time. So that is a massive limitation. If you want to run 2 shapes over the app, well, you could probably do it with 2 devices. If you want to run a whole stack of shapes, well, then you're going to have to do it over DMX. Now, there are some workarounds that you could do to get around this. For example, let's say you want 2 matching sets of InfiniBars doing a process on both sides of a motor vehicle, so it looks like it's traveling down a highway. Well, what you could do in that scenario is set up a massive arse pattern like this and then break it up into matching components. Now, having given you that as a solution, this is as good as I could get it. So I don't really have the space between the streaks that I would like, and I also can't do multiple layers of processing happening at different speeds that I can do with other apps. Okay, let's start testing the DMX. Now, I'm not the best person to be testing DMX on a pixel system like this because my DMX is one universe consisting of 8-bit profiles. So I don't really have the most elaborate setup for testing. So to make up for that, let's run a little bit of shameless aperture self-promotion first. All right, so the DMX testing does go on for quite a little bit in this episode because I've done essentially 2 loads of testing because these tubes work very differently or respond very differently over CRMX than they do over hardwired DMX. So what I found in my testing is if you have the smoothing turned off and you're running CRMX, they shimmer when they're getting close to their DIMMs. So if you want to do any sort of smooth transitions at all, over CRMX, then you definitely need to have the smoothing turned on. Now, the smoothing does lead to some delays in your cues. So my fear with that might be that if you're running CRMX and you're using these with other lights, you might be out of step with some of your cues if you're doing a slow transition or something like that. If you're doing an instant transition, so straight snap to a different color or something like that, then you don't need the smoothing turned on. Now, here's the other thing I found in my testing. If I'm running the cable DMX hardwired, you don't need the smoothing turned on. And the response times out of the tubes is sensational. It's absolutely 100% on point. Now, I don't have enough experience with DMX to understand why that is. I don't know if it's something to do with the programming or the infrastructure inside the tubes, or if it's because my Exolux control box here is outputting a higher frequency down the cable than it's transmitting. I'm not sure what the case is. Anyway, let's start off with CRMX testing first. I have the InfiniBar running off an 8-bit CCT HSI profile. It has its dimmer set to linear. It currently has its smoothing turned off, and it is receiving its commands via its internal CRMX receiver. To give you something to compare the response times to, I have an Astera Helios tube, which is also running off an 8-bit CCT HSI profile. It is set to its standard default dimmer, and it is also receiving its commands via CRMX. Both lights will be receiving their commands at the same time. Let's start off with instant on-off commands. Now let's do the same test again, but this time the InfiniBar has its smoothing turned on. The smoothing is on its minimum settings. Now for the rest of the testing, I'm going to leave the smoothing turned on. Now let's take a look at some half-second cues. Now let's take a look at some 1-second cues. Now let's take a look at some 2.5-second cues. And now some 5-second cues. Now let's have a look at some instant CCT changeovers between 5600 Kelvin and 3200 Kelvin. And for this first test, I have the smoothing turned off. Now we'll do the same test again, but this time with the smoothing turned on. Now let's have a look at some half-second changeovers. Now let's take a look at some 1-second changeovers. Now let's have a look at some 2.5-second changeovers. Now let's have a look at some 5-second changeovers. Now let's have a look at some instant changeovers between a CCT and a colour hue, starting the testing with the InfiniBars smoothing turned off. Now we'll do the same test again, but this time with the smoothing turned on. Now let's do some half-second changeovers. Now let's have a look at some 1-second changeovers. Now let's have a look at some 2.5-second changeovers. Now for some 5-second changeovers. Now let's have a look at how these bars perform off wired DMX. Now in order to run them off wired DMX, you're going to need this adapter. Now make sure you buy the Aputure adapter and not the Amaran adapter, otherwise it won't work. So this adapter has the USB-C port connector and your 5-pin XLR in and out, and a active little box here with a thread mount. Now of course you're going to have to figure out how to hide these on the tubes. Let's start off with instant on-off commands. Now let's take a look at some half-second cues. Now some 1-second cues. Now some 2.5-second cues. Now some 5-second cues. Now some instant CCT changeovers. Now some half-second changeovers. Now some 1-second changeovers. Now some 2.5-second changeovers. Now for some 5-second changeovers. Now let's do an instant switch between a CCT and a color hue. Now for a half-second switch. Now for a 1-second switch. Now for a 2.5-second switch. And now for a 5-second switch. Okay, let's start going through all the data I've collected, starting off with the dimming characteristics. According to my frequency meter, the dimming system on these lights is pulse width modulation, and set to its standard frequency, it's running at 20 kHz. Now, despite this being a fairly high frequency, I can still capture flicker with a 17,000th of a second shutter. So my gut feeling is if you're shooting at, say, 250 frames per second, this light would be flicker free, but if you're shooting up at around 1,000 frames per second, you'd probably catch some flicker. Now let's look at the dimming characteristics at 3200 Kelvin. I've taken readings at 100%, 50%, 10% and 5% brightness. As you can see, the CCT does drop, but only when you're very low on the dimmer settings. The color render is consistent, and the light does have ever so slightly a shift towards a green hue, but again, only when you're really, really low on the dimmer. In terms of the numbers on this green shift, it really would be imperceivable. Now let's take a look at 5600 Kelvin. With the exception of around 10%, the CCT is very consistent, the color render scores are consistent, and the white point placement or delta UV is also very consistent. Now here are the brightness readings off a 2-foot InfiniBar at a distance of 1 meter. And to give you something to compare it to, I've also taken readings with an Astera 2-foot Helios tube at the same distance, at the same time, with the same light meter. Now let's take a look at our CCT accuracies. From 2000 to 3000 Kelvin, the light is off the target value by on average plus or minus 10 Kelvin. From 3100 Kelvin to 4000 Kelvin, the light is off the target value by an average of plus 38 Kelvin. From 4100 to 5000 Kelvin, the light is off the target value by an average of plus 27 Kelvin. Between 5100 to 6000 Kelvin, it's off the target value by an average of plus 42 Kelvin. And from 6100 Kelvin to 7000 Kelvin, it is off the target value by an average of plus 51 Kelvin. Now let's take a look at the color render measured in TM30RF. Its lowest color render score is at its lowest CCT of 2000 Kelvin, with a very low score of 80. However, by 2100 Kelvin, this has jumped up to 91. And by the time you get to 2400 Kelvin, this has jumped to 95. So as you can see in the montage here, between 2000 Kelvin and 2400 Kelvin, there is a very sharp increase in color render and color accuracy. At 2400 Kelvin and 2500 Kelvin, the light scores are 95. From 2600 Kelvin to 3000 Kelvin, the light scores are 96. From 3100 Kelvin to 3400 Kelvin, it drops down to 95 again. From 3500 to 4500 Kelvin, it drops to 94. From 4600 to 5500 Kelvin, it's back up to 95. And from 5600 Kelvin to 6400 Kelvin, it drops back to 94. Now next up, we're going to talk about delta UV, or where these lights are tracking to, so what their white point is. Now I'm going to get a little bit technical here because these lights are doing something that's different to any other light that I've ever reviewed. Alright, so all full color gamut lights that are any good in their warm kelvins will track to the Planckian curve. Now the Planckian curve is based on superheated metals. So you've got metal that's heated up so that it's glowing warm or red hot, and you've got metal heated up so it's glowing white hot. So that's the difference between warmer and cooler kelvins. Okay, now the difference between most lights in full color gamut lighting is when you get up to daylight. Some lights will continue to track to the Planckian curve because that is a continuous standard. Other lights might track to the daylight curve, which starts at 5000 Kelvin. And some lights, like the InfiniBar, well, to keep everybody happy, they split the difference and go somewhere in between. So it doesn't matter if your camera's running to the daylight curve or to the Planckian curve, it's still going to look okay. This is a really safe bet. All right, so regardless of whether the light is tracking to the daylight curve or somewhere in between, at some point it has to start breaking away and going up from the Planckian curve. Okay, now most lights will do this at about 4300, 4200 Kelvin. Now, for some reason, the InfiniBars are doing this whole process about 1000 Kelvin earlier. All right, so what does that mean in terms of any sort of practical application? Well, if you're running your light at about, say, 4200 Kelvin, or pretty much anywhere above, say, 3500 Kelvin and below 4500 Kelvin, it's going to be tracking above the Planckian curve. So compared to your other full color gamut lights, these might be a bit green and you might have to dial in a bit of magenta correction. Also, if you're running these at this Kelvin point in conjunction with your bicolor lights, you might have to dial in more magenta correction than you previously are used to dialing in. From 2000 Kelvin to 3000 Kelvin, it is tracking extremely accurate to the Planckian curve with an average delta UV of minus 0.0005. From 3100 to 4000 Kelvin, it starts to deviate away from the Planckian curve, so I'm not going to give it an average. From 4100 to 5000 Kelvin, it is tracking above the Planckian curve with an average delta UV of plus 0.0017. From 5100 to 6000 Kelvin, it has an average delta UV of plus 0.0015, which splits it somewhere between the daylight and the Planckian curve. And from 6100 Kelvin to 7000 Kelvin, it has an average delta UV of plus 0.0011. Now let's take a close look at some of our kelvins, starting off with the lowest CCT that we can dial in. When I dialed in 2000 Kelvin, I got 2008. The TN30 colour render results were 80% average colour accuracy with an average 104% colour saturation. But take a look at the graph here. This is where averages can be misleading. Here are the CRI results, and as you can see, the graphic speaks for itself. This is the spectrum distribution. And the only positive at 2000 Kelvin is that the light has a really accurate white point with a delta UV of minus 0.0003. Now I'm also going to take a close look at these at 2400 Kelvin, because from 2400 Kelvin onwards, I don't think the CCT range is a gimmick. These are actually good enough to use as a key light. When I dialed in 2400 Kelvin, I got 2405. The TN30 colour render results are now a respectable 95% average colour accuracy with an average 104% colour saturation. Here are the CRI results. R4 is only just below 90 and R11 is below 90. Here is the spectrum distribution, and it has a very accurate white point with a delta UV of minus 0.0006. When I dialed in 3200 Kelvin, I got 3235 with an SSI score of 86. The TN30 colour render results came in with an average colour accuracy of 95% and an average colour saturation of 103%. With the CRI scores, R4, R9 and R11 are all below 90. This is the spectrum distribution, and it has a good white point with a delta UV of plus 0.0007. When I dialed in 4400 Kelvin, I got 4432. The TN30 colour render results were 94% average colour accuracy with an average 103% colour saturation. With the CRI scores, R8, R9, R11 and R12 are below 90. Here is the spectrum distribution, and the white point comes in with a delta UV of plus 0.0017. So if you're working to the Planckian curve, this would be slightly green, but still under the equivalent of a 1/8 correction gel. When I dialed in 5600 Kelvin, I got 5644 with an SSI score of 75. The TN30 colour render results were 94% average colour accuracy with an average 103% colour saturation. With the CRI scores, R9 and R12 were below 90. Here is the spectrum distribution, and the white point came in with a delta UV of plus 0.0015, which splits it between the Planckian curve and the daylight curve. Now let's take a quick look at some of the higher kelvins. I've taken readings at 6000, 7000, 8000 and 9000 Kelvin. When I dialed in the top Kelvin of 10,000, I got 10,729. The TN30 colour render results were 90% average colour accuracy with an average 99% colour saturation. With the CRI scores, R9 and R12 were well below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0011, which is a very accurate white point for such a high Kelvin. Let's take a closer look now at our primary and secondary colour vector hues. Red, which should be 0 or 360 degrees, came in at 1 degree. Green, which should be 120 degrees, came in at 117. Blue was smack on at 240 degrees. Yellow, which should be 60 degrees, came in at 65. Cyan, which should be 120 degrees, was quite close at 117. And magenta, which should be 300 degrees, was also very close at 296. Well, that's another episode of Gaffering Gear done, and just my closing thoughts on this. It's definitely not going to be everybody's cup of tea. I think a lot of people are going to want to stick with tubes over bars, and I think it really does depend on your clientele. For example, 10 years ago, I would have bought 4 of the 4-foot kits, and I would have had a chat to another gaffer that I used to sometimes team up with, and he probably would have bought 4 of the 4-foot kits, because the both of us used to do a lot of automotive work. We used to film a lot of cars, but that was back when Melbourne had a robust automotive industry. We had a Toyota plant here, we had a Holden plant here, we had a Ford plant here, and we used to do a lot of car work. And something like this, where you can create a continuous line of reflection onto a car, you need that continuous line to show the curves of the car's body. This was the holy grail. We just couldn't achieve it. But back then we only had fluorescent tubes as well. So this would have been a godsend. It would have literally been the holy grail for me. And bear in mind with this that this is made up of 2-footers. Okay, so that's pretty remarkable. It's not the most perfect joint in the world, but I reckon on reflections on products like cars, this kit would be awesome. Anyway, see you on the next episode of Gaffering Gear. Take care.